Hi, this is Steve with Roadrunner Air Conditioning, Heating, and Plumbing in Santa Fe. And today I'm joined by Sarah, who is another project manager in our company. And Sarah, when we are meeting with clients, we're often recommending mini-split, multi-zone heat pump systems to assist a client with their heating and cooling comfort. And I'd like you to spend a few minutes and tell us why we generally recommend that system for folks.
Right. So there's a variety of reasons that we tend to recommend ductless rather than ducted systems. First of all, you get zonal control. So each part of your home is going to be a different zone, and you're not going to want the same temperature necessarily in your master bedroom that you would in your main living space. And your kids might want their rooms at different temperatures, or maybe let's say you're not using a room much and you want to be able to have the control to turn that off entirely. So that's what we mean by zonal control. Each space can be regulated separately. They're going to be really quiet and totally customizable to each space. When we look at a floor plan, you can see on this image here that the lines that are run are no longer ducting lines. They're refrigerant lines that we can run in a crawl space or in an attic. Another big reason we recommend ductless is that it's going to be most likely qualifying for tax credits.
That's true. I forgot about that. Right. Now that's excellent. Because they're more efficient. That's why we're generally able to get the Energy Star equivalent ratings on these. Very good. So now let's talk about the difference between a ducted system and the ductless system that Sarah was just mentioning. The floor plan that Sarah showed you with the 5 zones and the mini splits throughout the home, it looks like it's complicated. But actually, it's not that complicated. Once you get those ducted and ductless systems installed, you simply control the airflow and the temperature with a remote control. That's up to you to set your desired fan speeds. The ducted system that most of our homes in Los Alamos have is actually deceptively simple. And that is, there's a central location for a furnace, and it has one thermostat. Seems as simple can be, that a furnace turns on, the fan turns on, the gas turns on, and the flames shoot out. And that's all you need to get heat in your house. However, it's deceptively simple because after you get that nice warm air in the furnace closet, you've got to move the air throughout the house into these various rooms around the floor plan. And that entails tubes, metal tubes, cardboard tubes, fiberglass tubes, which are called ducts. And they have to move the air through the house, and they come out the air comes out and registers around the house, either in the ceiling or in the floor. And then that air pressure needs to be pulled back to the furnace via a return duct, a return air duct. So it looks simple on the face of it, but actually becomes quite complicated. And we're going to look at 2 examples today in Los Alamos to show you some of those complexities and struggles that we have with our clients to optimize their heating and cooling systems. The first house is in Los Alamos. It was built in the 1960s, and it originally had 2 furnaces, okay? And it's about 2,000 square feet. So let's take a look at this floor plan, okay? Here is the layout of this Los Alamos house. It used to have 2 furnaces, but now has a single furnace in the garage, okay? 2 air returns, bring the air back to that furnace in the garage. And notice the complex series of tubes or ducts that have to move air to the various portions of the house. Now, in this particular house, the ducting is in the crawl space. And what is remarkable about this house is the client has gone through and measured the tube size of every one of those ducts. So in this floor plan, we can see that one duct is 8 inches, another duct is 5 inches, and another one is 7 inches. This is tremendous information to get. Very rare to get it. A lot of our clients have ducts that are in a slab built 30 years ago. Who knows what the diameters of those ducts are? All we know is there's a register and the air comes out. So the first thing about this house, really special that it has duct sizing. Second thing is, look at the nice placement of the ducting. The registers are all around the perimeter exterior of the home. And that is a wonderful location. So the air comes out along the cold exterior walls, and then the returns are centrally located so the air can be brought back into those returns. So, wonderful setup. If we zoom in on the bedroom section, which used to be handled by one of the furnaces, I want to also show you some of the complexities here in designing a duct. This is the as-built ducting system. I've circled the airflow in cubic feet per minute coming out of the registers in these three bedrooms and the office. And notice the high CFM load blowing through this single register for bedrooms 1, 2, and 3. 300 CFM, 302 CFM for bedroom 1. And our goal for supply registers is actually 100 CFM with a face velocity at the face of the register of 700 feet per minute. These parameters are designed to provide good airflow in a bedroom without a lot of noise. If you're pushing too much air through a register in the floor, for example 300 CFM, you will hear that airflow when the fan turns on in the furnace, and that can wake you up and disturb your sleep in a bedroom. So in bedrooms, we always strive to have around 100 CFM of airflow coming through the register. The face velocity, the speed of the air coming out of that register, is also important. Is another one of these complexities in ducting that we don't think about. 700 feet per minute of airflow is designed to get the air off the floor, bring it into the room so that the room can circulate, have warm air circulating, and be comfortable. If there's not enough airflow or not enough air speed, the air just sits over there in the corner by where the register is and doesn't get to where the people might be at the other side of the room. So the combination of CFM as well as face velocity are both parameters that have to be designed into the ducting system, which is built 50 years ago and it's in a slab. So very seldom do we have a good ducting system for our clients. And this gets back to what Sarah said. We solve a lot of problems with existing ducting with a mini split system, because you can put the unit on the wall, you can decide the airflow and the speed and the temperature in every zone. It's just a wonderful thing. So that's example number 1 in Los Alamos, a wonderful as-built structure with lots of complexity, but at least the ducting is in the right spot, okay? Now let's talk about example number 2 in Los Alamos, a house that's about 20 years older than the first example. It's a 2-story house in Los Alamos, and this actually has very poor ducting design, unfortunately. Take a look at the supply and return ducting in this home. The register for the supply is in the ceiling area, and then the return is actually down at the bottom of the same wall. So what happens in this kind of a space is the air blows out the supply and is sucked right back in through the return and back to the furnace. And then the airflow doesn't get to the other side of the room where the people may be sitting. The second problem in this particular design was the ducting actually is on the inside wall of this living room. Take a look at this schematic from the Amply Energy 3D scan. Notice that I circled the wall, the inside wall where the return and the supply are located. The big window, the cold window, is the exterior wall and the front door. So we are 20 feet away from where the cold wall is, and we've got a supply and a return on the same wall. So difficult to use this kind of a ducting system and get adequate heating in the winter in the Los Alamos home. It's just sad that they were built this way, but once the 2-story house is built, you can't change the ducting. You just can't move these ducts to a new location. The second photograph is a bedroom. And again, it shows in the circle of the 3-dimensional picture where that supply duct is located up in the ceiling. It's on the wrong wall. It's on the interior wall, and the cold windows, the exterior, and this is on the wrong side. So we often are in a situation where the client would like to put in a brand new gas furnace and blow the air through the house. But when we get into the details of the ducting, we find that the ducts may be inadequate. They may have the wrong diameter. They may have the wrong registers. They may be on the wrong wall, and the returns may be in the wrong location. They may be too small. Maybe it's too loud. Maybe it's inadequate with CFM of airflow. So this is why I think in some, Sarah, why we end up recommending the mini split system. It's such a great solution. It provides the heating and cooling that we need in Los Alamos and in northern New Mexico. Thanks for listening.